Okay, so we just figured out how to solve this particular problem, and we want to prove that it's graphed. Now these are a little more difficult to graph because neither one of these variables is isolated. And so you're going to have to put it in slope-intercept form. I'm going to go ahead and just put negative 9, 7 up here. So I'm going to go negative 9, 7. And graph that. And I wrote the equations out here so that you can see that you have to put this in slope-intercept form, which means you have to subtract both sides by 3x. That's going to give you 2y. This is going to cancel out. You have 2y equals negative 3x plus it's a minus 13. Then you're going to divide each term by 2. Now what's tricky about this here is that you're going to have negative 3 halves x minus 13 halves, which is 6.5. So your slope, your y-intercept here, your b, is negative 6.5. So when you go to graph that, you have negative 6.5, which is right here, and your slope is negative 3 halves. So I could go down 3, 1, 2, 3, and to the right 2. But that's not going to get us up to where our interception point is. So I'm going to go up 1, 2, 3, to the left 2. 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 I think I didn't count this over right. Let's see here. 2, 4. So it's got to be on these points. So I think I got off here. Hold on 1 second here. Because it should go through the even numbers. So if I have this here, 1, 2, 3, to the left 2. 1, 2, 3, to the left 2. That's it. 1, 2, 3, to the left 2. So now, although when we're graphing this line, it didn't go through the whole number that we wanted, and we're used to that, the line actually does cross at negative 9, 7. So for the next one, we have 3x plus 4y equals 1, where we're going to subtract 3x from both sides. So now we have 4y equals negative 3x plus 1. Divide each term by 4. So y equals negative 3/4 x plus 1/4. So my y-intercept is positive 1/4, which is just above here, just above 1. And I have a negative slope, but I'm actually going to count up this way since I see that this is where I want the line to intersect. So I'm going to go up 3. So that's going to be 1, 2, 3, and to the left 4. So that's my negative 4. And up 3. Let's see here. 1, 2, 3. And to the left 4. Just above 1. 1, 2, 3. And to the left 4. 1, 2, 3, and to the left 4. It's going to be over here, but you're going to see that the line does cross at negative 9, 7. Okay? For this last one, you can see that only one of the variables is isolated. So since one of the variables is isolated, we're going to use the substitution method. So why? Because only one variable is isolated. So you can see that since one variable is isolated, I like to put it in parentheses, and this is what I'm going to substitute for the value of x here. So I'm going to put 3, and instead of x, I'm going to put y minus 4 plus y equals negative 20. Then I'm going to distribute the 3 to each term, so that's going to give me 3y minus 12 plus y equals negative 20. I combine my y terms, so now I have 4y minus 12 equals negative 20. Oops. if I add 12 to both sides, it's going to cancel the 12s out. I'm going to have 4y equals, I have negative 20 plus 12 is going to give me negative 8. Divide both sides by 4, y is going to be negative 2. So y is negative 2. Now I'm going to take that value and plug it into here to solve for x. X equals negative 2 minus 4. So x is going to equal negative 6. Why? Because this is a negative 2 and this is negative 4, same sign. Or you could keep change. You can still see same sign, same sum, keep the sign the same. So my solution is negative 6, negative 2. So now when I go to graph these, I still want to put them in slope-intercept form. So I'm going to rewrite the equations over here. 3x plus y equals negative 20. And I'm going to subtract 3x from both sides. And I'm going to have y equals negative 3x minus 20. And you can see I did not leave enough room on this graph for you to graph that, but I'll show you how you can solve it. And the next one, because you can see that my m is negative 3 and my b is negative 20, and I don't have 20 on here, so that's not going to work on graphing, but I'll show you still how we can do that. And then the next one is x equals y minus 4. So if I was going to do this to isolate it, I would simply add 4 to both sides. So now I basically have y equals x plus 4. Or my slope, this I can graph. So if I'm going to graph this one, that's positive 4. Okay, and my y-intercept is negative, or is, I'm sorry, my y-intercept is 4, and my slope is positive 1. So it's going to go through the diagonals. My solution was negative 6, negative 2. So that means, and that's the problem here, is that it's going to be off the graph over here. Negative 6 is going to go right here, and negative 2 is going to be here. So you can see here's where the solution actually is, where the lines are going to cross, is at this point. One thing I can do though is if I had this and I have that my slope is a negative 3, I can I can go up 3. So if I go up 3, 1, 2, 3, and to the, or actually I'll go down 3, 1, 2, 3, into the right one. This was the other line that it should have been. Okay, so it's off the graph, but you can still see that it would, those two lines would intersect. For me, it's less about the graphing, that just proves that it's right, and it's more about, do you know which method is the best? Transitive property, when both of the variables are isolated, elimination/combination, when none of the variables are isolated, and substitution, when only one of the variables is isolated. Hope this helps.